T-distributed stochastic neighbor embedding, or t-SNE, is a powerful technique for visualizing high-dimensional data. Unlike PCA, which preserves global structure, t-SNE focuses on preserving local neighborhoods. Let me show you how it works. We'll start with data in high-dimensional space. For visualization, we'll create 3 distinct clusters in 4-dimensional space. But we can only show 2 dimensions at a time. Here we see just 2 of the 4 dimensions. The colors represent different clusters that exist in the full 4D space. Notice that in these 2 dimensions, the clusters may overlap or appear close together. t-SNE begins by converting distances between points into probabilities. Nearby points have high probability of being similar, while distant points have low probability. This creates a probability distribution in the high-dimensional space. The probabilities are calculated using a Gaussian distribution, so that only nearby points have significant similarity. This focuses on preserving local structure rather than global distances. Next, we create a random initial layout in 2D space. We'll optimize this layout so that the similarity probabilities in this low-dimensional space match those in the high-dimensional space as closely as possible. Now we optimize the 2D layout using gradient descent. The algorithm adjusts point positions to make similar points in high dimensions close together in 2D, while keeping dissimilar points apart. Notice how the clusters that were mixed together in the original 2D projection are now clearly separated. t-SNE has preserved the local neighborhood structure from the high-dimensional space. A key innovation of t-SNE is using AT distribution in the low-dimensional space. This heavy-tailed distribution helps prevent the crowding problem where points would otherwise collapse together in the center. In summary, t-SNE is particularly effective for visualizing high-dimensional data by preserving local neighborhoods. It reveals cluster structure that may be hidden in other projections, making it invaluable for exploratory data analysis.